Good morning to all. Welcome to the today's lecture about series circuit. Before entering to the topic, let us recollect the fundamental concept of electricity for a few minutes. Let us see what we saw in previous classes. We studied the fundamentals such as what is voltage, current, and also what is resistance, and what are the resistive elements, and about the Ohm's law, how it is directly proportional and inversely proportional to current and voltage. So let us see today in today's class what is series circuit. For example of series circuit is that a picture of a single road where car must travel in a one behind the another. So there is a no exist or a shortcut. This is an example of a series circuit, which means a closed loop with the components like resistor, bulbs, or battery are connected end to end along with one path of current flow. That is said to be your series circuit. So this diagram represents the example of the series circuit. So how you imagine a road where car must travel. Only only there is one path of travel. So every car will travel one behind the another. There is no shortcut and exist. Similar to that, the current flows in the series circuit. And the current only flow through only in single direction. There is only one path for current flow. So this is the definition of the single. This is the basic definition of series circuit. And here current in electric cars, the flow from the battery power terminals through each component and back to the negative terminal. So if one component may fails like or burned, for example, if the bulb is burned, the whole circuit breaks, just like a traffic jam halting all the cars. This is all or nothing behavior defines the series circuit. For example, so if you're traveling in a single road where one car travel behind the another, so that there is no exit or shortcut. In such cases, if any car has become fault, what will happen? The other cars are will be in standing position. There will be a heavy traffic jam. Similarly, if one component fails or burns out, the whole circuit is breaks. That is the main drawback of series circuits. So here are three key rules. That is, key rule number one is about current. So in series circuit, the total current flowing through this circuit is where that is equal to the total current is equal to the I1, I2, and I3. So because the same current flows through the directions, there is only one path of current flowing through the direction. And the key rule number two is that about voltage. Here the voltage is equal to V1 plus V2 plus V3. The total voltage is equal to V1 plus V2 plus V3. So the supply voltage is addition of every voltage across the circuit. And next is key rule number three is about the resistance. Here the total resistance is R1 plus R2 plus R3 based on the circuit. So the total resistance equal to the summation of resistor in each path. So the main key players are about voltage source, which supplies the energy measured in volt, and also loads something like resistors or light, which uses the energy measured that is measured in ohms for resistance, and current is something that the flow of charge, which is same everywhere in the series circuit, and that is also measured in amp. So these three are the main key properties. So in series circuit, the current remains constant throughout the circuit. Think, for example, think water flowing through a single pipe. The flow rate does not change, even the pipe narrows. So that is an example for current flow in the series circuit. And however, voltage divide among the components based on the bulb, based on the resistor or the bulb. The voltage has been divided, and the total voltage is equal to V1 plus V2 plus V3. Here the each resistor which is connected to the circuit, which is proportional, the voltage is it's exactly proportional to the resistance. The voltage starts according to the resistance. And also the resistor is something that how to calculate the resistance. R total equal to R1 plus R2 plus R3. So the bigger total resistance means less current for given voltage. So let us see about Ohm's law in action. Okay. So here the Ohm's law plays a vital role in performing the calculation of series and parallel circuit. So you all know about the formula for voltage. Ohm's law is that V equal to I into R. Imagine here in this given example, the value of R1 is 2 ohm and R2 is 3 ohm and R3 is this value. What is the formula for calculating the total resistance? RT equal to R1 plus R2 plus R3, which means 2 plus 3 plus 5. So what is the total answer is 10 ohm. So imagine if you have a 12 volt battery powering with the 4 ohm resistors, which means the total value of the resistor is 4 plus 4, 8 ohm, and the current flow through the resistors I equal to V by R, which means 12 by 8 ohm. What is the current flow through the resistor is about 1.5 amps. And the voltage drop across the resistor is, for example, for resistor R1, that is V1 equal to I by R1. So that 1.5 divided by 4, that is equal to 6 volt, and also similarly for V2 it is 6 volt. And let us see a few more example. So in this problem, the given elements is that V equal to 20 volt and R1 equal to 4 ohm and R2 equal to 6 ohm. You all know the total resistance formula for series circuit is R1 plus R2. So 4 plus 6 is 10 ohm. And according to Ohm's law, what we have to find? We have to find the current. So the current is equal to I equal to V by R. So here 20 by 10. So the current flow through the circuit is 2 amps. Next, let us see the from current, that which what we guess is that I equal to 2 amps. Let us see the voltage drop based on the resistor. So here the resistor values are around 4 and 8, and also here v equal to I into R1. So here 2 into 4 is 8 volt, and also here V2 equal to I into R2, that is 2 into 6 is 12 volt. So the total voltage is that 8 plus 12 is that is equal to 20 volt. And next, let us see the problem with 3 resistance. Here the given voltage, terminal voltage is 24 volt with the resistor value 2 ohm, and another resistor value is 4 ohm, another one is 6 ohm. So the step 1 is to find the total voltage, that is 2 plus 4 plus 6, that is equal to 12 ohm. And step 2 is I equal to V by R. So the total voltage given is here 24 volt and R is 12, that is 2 amps. So here based on that V1, V2, V3 has been calculated, and they have found the voltage across the each resistors. So what happens if one resistor fails? If one resistor fails around the circuit become a failure circle, because the component breaks in the circuit fails, and the failure creates an open circuit and no current flows through the circuit, and the device will be stopped working. That is the main drawback of series circuit. And let us summarize. So series circuit characteristics and its formula. So here the series circuits are single path, and it acts as a voltage divider, and it is a failure impact, and the current pass through the same current pass through entire circuit, and the total resistance equal to summation of all the resistance, and you have to find the three formulas for the series circuit for calculating the total resistance, that is R1 plus R2 plus R3, that is summation of resistance. For current it is equal to V by R, and for voltage it is equal to I into R. I hope you understand about the topic of series circuit. Let us see some series circuit behavior. Why does the current remains the same in series circuit? In series circuit there is only one path of current flow, so the current must be same everywhere at the point, at any point. So what happens, the total resistance if more resistor is added in series. So adding more resistance in series increase the total resistance in the circuit. And in series circuit, one bulb fuses, what will happen? The one bulb fuses, the current circuit is open, and the circuit is broken, and there is no current flow throughout the circuit. That is the main drawback, and also there won't be any glow. So based on this circuit behavior, you learned about the series circuit has only one path of current, and more resistance there is a less current, and no current if bulb becomes failure. I hope you all understood the session. Thank you.